Yeah, so you're welcome to today's lecture. We are beginning with numerical techniques to systems of linear equation. And like I told you last week, you needed to go back to your elimination techniques, okay, to assist you uh, in today's class, to assist your comprehension of what will be taught in today's class. So Saki, kindly do me a favor, inform your colleagues class have started, and let's continue. Welcome to today's class. Looking at Gaussian elimination as an introduction to solutions to systems of linear equation using numerical methods. So what we are saying today is given any system of equation, okay, of any dimension, at Gaussian elimination as an introduction to solutions to systems of linear equation using numerical methods. So what we are saying today is given any system of equation, okay, of any dimension, in the lower stages, we looked at 2x2 systems and 3x3 systems. That's equations, 3 equations with 3 unknowns. That makes up a 3x3 system, right? Here we are looking at a system of any dimension because real life systems go beyond 3x3, 4x4 systems of equation. So we are saying that if we have a matrix or a system of equations of n equations with size n, okay, and we are supposed to solve for it, how do we go about it? Now, the challenge here is the bigger the matrix, the more difficult analytical techniques become. And also, we all know that analytic methods become, let's say, more involving and time consuming, okay, as the system increases. And in real practical sense, if you're looking for a solution, a exact solution to a system, and you have to spend like 5-10 minutes in a critical condition, then it becomes a challenge. Hence the need for an iterative, or let me say a numerical approach, okay, where we allow the computer to do the solution, to find the solution of the system for us. But that's just a click of a button and you have your answer. Now, Gaussian elimination is an approach which is used to get the solutions to any given dimension of equation. Okay, so it says in these equations, if we are giving aij, where ai's are the coefficients of x and bi's are the solution, okay, that's any given real numbers. We can write them in the form ax is equals to b. That's the general form, okay, where a is the coefficient matrix whose element in the ith row and jth column is aij, and the B is the column vector or the solution matrix whose ith entry is bi. This gives us an easier way of representing the equation as what? A11, A12, A13 to A1, and then you write the corresponding rows. So it goes Aij, where I are the elements in the row, and J is the column of the matrix. So for example, A21 is the element in the second row, first column. A22 is element in second row. Now, the task in Gaussian elimination is first to reduce the augmented matrix to an upper triangular matrix, and then two, to solve the resulting matrix using a backward substitution approach. Now, this is what we mean by an augmented matrix being transformed to upper triangular matrix. So in this case, if we're giving, for example, a 3 by 3 matrix like this, and we write it in the form A, X, B, okay, then we're going to transform all the elements under the leading diagonal here, where you see the line. Okay, so this value should go to 0. This should also go to 0, okay, and then this will also go to 0, like we can see over here. Over here. Okay, so all the elements below the diagonal should go towards 0. Good. How do you do that? You can use the elements in the first row, that's A11, to reduce the elements in what? A21, and then the element in what? A31.
So for example, you want this element to become 0. Okay, so what you can do is, in the augmented form, okay, of course this part will not be there, right? You're going to have a row operation. This is row 1. Let me put this row 1. This is row 2. This is row 3. Okay, so if I want this element, the objective is to make these 3 elements to become 0. So everything under the leading diagonal, okay, becomes 0. How do I achieve that? And we said that we can use the element in row 1 to reduce this element to 0. How do you do it? This is 2. Okay, so for 2 to become 0, all you need to do is to multiply row 1 by what? 2. Okay, we multiply by row 1 by 2, and then come and subtract it from row 2. So you need this operation, which will be what? Row 2, okay, row 2 minus what? Minus 2 times of row 1. Okay, so if we work this mathematical operation out, then it means that this element here will go to what? 0. Okay, whilst other elements will also change in the given what? Row. Okay, but the objective is to make this leading coefficient here to be 0. The same way, if I have to change this 3 to 0, I can also use row 1 to reduce that. That will be row 3 minus what? 3 times of row 1. Okay, so that operation will help me to get this to be what? To be 0. Then after you finish reducing elements in the first column here, okay, then you can come and select another what? Another pivot or another row which can be used to reduce this other element to also 0. Okay, so first of all, you use the leading coefficient in row 1 to reduce all elements below it to 0, and then you pick the leading coefficient in the next row to reduce elements under it to 0. If it is 4 by 4 matrix, you go to the next row, use the leading coefficient to reduce other factors below it to 0. Okay, so let me clear.
Okay.
Yeah, so one last thing. So after you've reduced everything to 0, then the next step will be to solve the resulting matrix using a backward substitution. How do you do that? You just rewrite the matrix, okay, in the algebraic form. Okay, so this will look just like that. That will be x plus 5y plus 7 is equals to 20. These are not the actual values you get, but just for demonstration. Okay, then because this is 0, x is missing in the next equation. So we'll get negative 3y minus 4z is equals to negative 36. Then because these two elements are 0, x and y are both missing. So we are left with z. So it will be negative 2z is equals to this. Then backward substitution means you first find z. So z is going to be what? Will be negative 159. Or yeah, since they are both negative, so we'll get z to be 159, okay, over 2, okay. Then once you get that, you use a backward substitution, means you come and put it into the second equation to find y. And then once you get your y, you put the z and the y also into the first equation to find x. That is why it is called what? A backward substitution. So you are solving from down to what? To top. Okay, that's why we call it as a backward substitution. So that is the whole idea. And let me mention once again that this is not the actual solution to the system. It's just for demonstration for you to understand the process of backward substitution. Okay, any question? Any question before we move on? Okay. So without any question, it assumes that we are okay.
Hello, sir.
Yes.
Sir, please, can you come back to the solution, like the first step?
Yeah, so what I'm saying is you need an operation to change this to 0. Okay, this is row 2. So you can do row 2, okay, minus 2 times of row 1. 2 times of row 1 means when you come here, this element is 2. So 2 times, this element is 1. So 1 times 2 will give you 2. And then when you do the algebraic operation, 2 minus 2 will give you what? 0. Okay, so that will help us to achieve the objective of this element in row 2, column 1 to become what? 0. Okay, so that is how you derive your operations for reducing the matrix to an upper triangular matrix. But further emphasis will be laid in the next example. Okay, so let's continue.
Okay, now these are some operations, or these are the general steps in Gaussian elimination. Like I said, first you have to reduce the augmented matrix to an upper triangular form. Then secondly, we apply row operations. There are 3 operations that we can apply, okay? And these iterations must be clearly stated. All operations used in reducing the matrix should be clearly indicated at the proper place. And like I said, there are 3 main operations. We can multiply a row by a non-zero constant, and then we can also add a multiple of another row to a given row, okay, to reduce it. Or we can swap two rows. So like we can see, this is the case where we are adding a non-zero constant of row 1, okay, to row 2 by subtraction. Then step 3, you have to solve the resulting matrix using the backward substitution. Yeah. So we have an example.
Okay, so there is an example here. I think I'll have to address the sound is not too clear there. So we are supposed to solve this system of linear equation. Okay, and just a minute, let me clear the sound and then speak to it. Else it's going to disturb. Yeah, okay, so there's a question we are asked to solve. We're given a 3x3 system. And like we said, to solve any system using the Gaussian elimination, the first step is to rewrite the given the algebraic system in an augmented matrix form. Okay, augmented matrix form means you are going to write it in the form A with the coefficient matrix with what? The solution matrix. Okay, that is the augmented matrix form. Okay, so that should be, let me just demonstrate here. Then afterward, we'll look at the solution. So that will be 1, 5, 7. Okay, then we have 2, -3, 4. And then we have 3, 1, -2. Then you have the solution, which will be 24 and what? And 9. Okay, so that is the first step in the Gaussian elimination technique. Okay, and at this point, I will advise you get your calculators with you before we proceed. This is the augmented matrix of the system, okay, which we've just seen, okay, which is in the form A, what? A and B, okay, the matrix A and B, okay. That is the augmented matrix of the system. Now, what's next? The whole idea in the Gaussian elimination is to, first you have your leading diagonal. So we need these elements to go to what? To 0, okay? So we are going to use operations on matrices. We said that 3 operations which can be done. We can multiply a row by a non-zero constant, okay, and then we can add what? The multiple of one row to another, okay, and we can equally also subtract one row from the other, okay, and then we can also interchange rows. These are the 3 basic operations we can have in Gaussian elimination. So let's see the steps involved in reducing this matrix to obtain the upper triangular matrix. So this is how it's going to look like. Okay, the first step will be, we're going to have the operation R2 minus 2 times of row 1, okay? R2 minus 2 times of row 1. So this is row 1, this is row 2, this is row 3. So we have R2 minus 2 times of what? Row 1, okay? Will help us to get this to be 0. Good. And then let's see the next operation. So for third row 3, that will be R3 minus what? 3 times of row 1, okay? Now let's see the computation in how this is what we are going to get, but let's see how the calculation is actually done. Because you are saying R2 minus 2 times of row 1, this is how it's going to be. For the first element here, it will be 2 minus 2 times 1. Okay. Okay, this is the one here. I hope you are following. So let me clean this one here. Yeah, so it is this 2 minus 2 times of this 1, which is 0. Okay, so that is the 0 you have here. Then the next one will be negative 3 minus what? 2 times of the 5. Okay, the 2 multiplies the whole of row 1. You understand? So 2 times 5. So that will be negative 3 minus 10, which is negative 13. Okay, so that gives you the negative 13 you have here. Then the next one is 4 minus 2 into bracket what? 2 into bracket 7. Okay, so 4 minus 2 into bracket 7 will give you 4 minus 14, which is what? Negative 10. Okay, which is this negative 10 here. And then the last one will be what? 4 minus 2 into bracket what? 20. Okay, which will be 4 minus 40, which is negative what? 36. Okay. So that gives us the value we are getting here. I hope it's clear to everyone. If it's clear, just give me a yes by chat. Okay. Just give me a chat yes and let me acknowledge you. Okay. 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 13 says I should go over. So 13, the operation is row 2 minus 2 times of row 1. In other words, you are multiplying row 1 by 2. Okay. So this will become 2. This will become 10. This will become 14. This is what? 40. Okay. Then you come and subtract that 2 times of row 1 from row 2. So it will be 2 minus 2. Okay, which will be 0. Then you have negative 3 minus 10, which will be negative 13. Then you have 4 minus negative 14, which is negative 10. And then we have 4 minus 40, which is negative 36. I hope it's okay now. Can I get a feedback from you? Okay, good. Very good. Yeah, so the next step is to also reduce this element to 0. This one too should go to 0. So we have 3. Let me clear the first operation. So that this time the operation is what? Row 3 minus 3 times of row 1. Okay. So indirectly you are multiplying row 1 by 3. Then you go and subtract it from what? Row 3. So 1 times 3 is 3. 5 times 3 is what? 15. 7 times 3 is what? 21. And then 20 times 3 is what? 60. Okay, so you go and subtract the 3 from here, from 3 here. You understand? So 3 minus 3 will be what? 0. Then 1 minus what? 15 will be what? Negative 14. Then negative 2 minus negative 21 will be what? Negative 23. Then 9 minus what? 60 will be equal to what? Negative 51. Okay, good. So this is the first operation. Okay, so we have this operation, that operation, which has reduced all the elements under this first, okay, leading coefficient in row 1, column 1. We've reduced every element to what? To 0. So once you are done, you cannot make use of row 1 again. The objective here is to change everything under the leading diagonal to 0. This has to go to 0. This has to go to 0. and this also has to go to 0. We have achieved these two, okay? This is achieved, this is achieved, but we are left with this element here, which is row 3, column 2, okay? Now, to change row 3, column 2 to 0, you cannot use row 1, because if you attempt using row 1, you come back and then come and change the zeros you've created here, okay? So the next element, or what we call as the pivot we're going to make use of, will be what? The element on this row here, okay? The new element on this row here. So that will be, we are going to use this negative 13 to transform 14 to what? 0. So the question is, how can we do that? Okay, one way of doing that is to multiply this row by what? 13. Okay, so we can have 13 times of row 3, okay, minus what? 14 times of what? Row 14 times of row what? 2. Okay, so 13 times of row 3 minus 14 times of row 2, and you're going to do those calculation for me. So get your calculators ready. So 13 times of row 3 minus, so 14 times of row 2, 13 times, let me clear this side. So we are coming to multiply them, right, before we subtract. So 13 times 14 should give us what? 13 times 14.
182.
182.
Okay, let's do this. I have less than 1 minute for the first 45 minutes to end. So write it down and then do the calculation so that by the time I come back, you are finished with the calculation for me. So write the matrix down and do the multiplication for me.